Good day, everyone. Today I'll be here representing my group, which consists of Michael Joseph, Calvin as Halim, and Rowin Faadhilah. My name is Jeconiah Richard from Binus, and I'll be the presenter for today. Today's presentation will cover four main sections, which will go through the introduction, model and techniques, result and discussion, and the conclusion. First of all, we begin with the introduction. Since our title mentions style transfer, I would like to explain a bit about it. It is an algorithm that takes two input images and blend together the two images to create a new one, with the same content from an image but using the style from the reference. In this case, the content image is Mona Lisa, and with the addition of the style image, it will result as follows. Then a short brief about CNN. It is a deep learning algorithm which can take in an input image, assign importance, learnable weights and biases to various aspects or objects in the image, and be able to differentiate one from the other. There are two models that we're using for our neural style transfer, which are VGG 16 and 19. For VGG 16, Casey Monyan and A. Zisserman from University of Oxford presented this as a convolutional neural network model in their article of very deep convolutional networks for large-scale image recognition. This model obtains 92.7 top 5 task accuracy with dataset over 14 million images and 1,000 classes.
Sorry, Jack. I think your slides are not changing.
Oh, is it?
Yeah, no, now it's changing.
Oh, okay, maybe. I apologize for my internet connection. Is it now on introduction slide? I mean the model slide.
Yeah.
Okay, cool. The model we're using, as I mentioned before, are VGG 16 and 19. For VGG 19, the numbers in the model are slightly, it has a slight difference with the VGG 16. It refers to the number of weight layers that the model has. That being said, the pooling layers of VGG 16 and 19 will have a slight difference, where the 19 will have one extra layer being used as the featured space. In short, the VGG 19 model has a higher capability to extract the texture or features such as curves, edges, background of the content image compared to the VGG 16. For our paper, we use Batik as our style image. The previous models and architecture were applied with the goal of Batik style transfer. For those who don't know, Batik is a product of coloring design on textiles by dyeing them with wax resist. It is the embodiment of Indonesian art culture and is deeply rooted in our day-to-day life. On the 2nd October 2009, there's a short history of Batik. Batik was declared to be a humanitarian heritage for oral and intangible culture by UNESCO. The related work, similar studies have performed neural style transfer between famous paintings and a variety of content images that range from animals to buildings and even people. They perform the style transfer using a similar VGG model with 16 layers and did not go as far as to apply to Batik style patterns. Further research has attempted the neural style transfer, this time on Batik. The produced image was produced through VGG 16, whilst implementing an extra colors cost function to minimize and account for. In hopes of obtaining a more solid color, the Batik pattern was passed through a k-means algorithm to assemble the clusters of colors that can be found in the Batik style image. There are some patches of dull coloring around the image, which is not ideal. Additionally, an algorithm was developed which takes a sample image and a user-drawn target pattern and creates an image that is visually similar to the base image drawn in the user-created pattern. However, there is an extremely obvious constraint in this algorithm which refers to its low-level feature of the target image. This constraint implies the prerequisite of finding target pattern image representation to draft its base model, variation style must be satisfied. For the model and techniques, the architecture of PGG16 are shown in the image, where the input layer takes an image of size 224 by 224 by 3 and output a softmax prediction on 1,000 classes. The feature extraction portion of the architecture is highlighted in red, as you can see in the picture, with the size of 7 by 7 by 512, while the rest of the network is the classification part of the model. So this is the difference between the two model and the form of the table. As mentioned before, the main difference, as the name states, is the amount of layer between the 16 and 19. We can see that the 19 has a higher number of layers and more varieties of filter sizes. We can also note that the ReLU amount of the VGG19 is significantly higher. In this case, for the 16, it has 5 and 18 for VGG19. A short brief about ReLU. It is short for rectified linear unit. Neural network require an activation function to be responsible for transforming and some weight input from the node into an output. ReLU is a piecewise linear function that will output the input directly if it is positive, otherwise it will output 0. It has become the default activation function for many types of neural network. In short, because VGG19 has more hidden layer, the number of ReLU also need to be increased to help the vanishing gradient problem. Next, this is the formula we're using for our paper. This content loss formula is to ensure that the generated output image X contains some of the global characteristic of the content image. So to balance out between the content of the base and the style. Then for the style loss, the first picture is to calculate a style matrix by using gram matrix for generated image and style image. The second formula for style loss function for layer 1. And the last image is for total style loss
I
function.
think the slides are lagging again. We cannot see the images.
Okay. Here it is. I'm sorry.
Yeah.
Then this is the full architecture of our program. In this case, we're using Komodo as the content image or the base, and with the addition of a green pattern batik image, and it will be shown in the result and discussion. First of all, this is our first test subject, where the base image is image of cat and Picasso's art, and this is the result for after using VGG16, I mean, and this one is the result of VGG19. To note the difference between the model of VGG16 and 19, this content and style image are run in both models, and here is the time taken table for the iteration. The time varies due to the machine specification as well. This is the second test that we ran. It is an image of otter and another batik style pattern. And as we can see from the picture of test 2, here it might be considered as a failure because the feature of the content image or the otter cannot be seen at all. We can only see the shape of the batik, but there's no significant visible otter image here. One of the reasons that we think caused this issue is because the style image is too monotonous, so there's not much variation in the pattern and no gradient in color whatsoever, so we decided to try another set of image. This image is the combination of the Komodo and batik, as I mentioned earlier, and this is the result of its combination. since we couldn't see the features of the content or other image previously, we decided to increase the content image influence on the result image with hopes that this time the shape of the animal would at least be seen. But once the result was produced, it seemed as though the influence was too strong, so we decided to run it again with less emphasis on the content image. Because Batik is not really about seeing the animal, but we put more focus on the pattern or style. So this is the result of it. Just to remind, all these images are generated with 600 iteration as the standard, as it takes quite a good amount of time to generate, roughly around 12 hours for 600 iterations. And this other, we make other examples for the combination. Maybe it's a little hard to see for the image on the left, but actually that because the image was resized to fit in the slides. We can see the Komodo's stature in both the images while still implementing the batik style pattern successfully. For the conclusion and recommendations, we demonstrated how to make use of deep convolutional neural network to perform feature extraction and transfer image style between two images. And we experimented on the relative influence of the content and style images. We use VGG19 architecture instead of 16 because the added layers in the architecture was able to pronounce the content image features more and produce a number of new batik patterns that represent the mesh between a batik pattern and the Komodo. For the recommendation, an issue that might be overlooked by some is the effect that running these overnight simulation have on our device's processors. The processor is measured to go up to 86 degrees Celsius multiple times with an average high of 82 to 83 degrees Celsius. For the researchers, should be careful to not running the program in a warmer climate as it might deteriorate the processor's lifespan. We also recommend that better graphics card be used to help lighten the load of the image processing. Currently, our program is limited to projecting the style of single image onto the content image. So further studies or research might want to develop the idea to combine multiple images and combine it to the base. And a rough idea of recommendation might include blending the weights of the different style images into a single array with equal weighting and normalizing those weights to sum to 1. And there's a short quote here before I ended the presentation, generated by AI that seek success but prepare for vegetables. Thank you.
Thank you, Mr. Michael Joseph, for the presentation. Now, if anyone has any question, please put your question in the chat or raise your hand. Any question? Mr. Michael Joseph, please allow me to ask.
Okay.
Can you share with us about the future changes and challenges of your research? Thank you.
The future challenges would be, first of all, as I mentioned before, this combination of both image takes a lot of time to produce, and a single run for the program would take roughly around 12 hours for each 600 iteration. So running these will take much time, and That's why we recommend a better graphics card to run this faster, and also finding the right alpha and beta value for the program would be ideal for further research as well to make the best combination between both base and the style image.
Okay, thank you. I think the Q&A time is over and we should go to the next presentation.